the next speaker is Gruno from Tatel, also known as a big company in software and presentation techniques, but connection with synthetic aperture radar analysis, this is quite new, and for non-specialist it is indeed surprising that this radar data can be used for measurement in centimeter level for some cases, or Antti may explain what is the precision of height differences. Okay, Antti, the floor is yours.
Hello. Do you hear me?
Yes.
Do you see my slides?
Yes, also these are visible.
Thank you. I'll be honored to make presentation in such seminar, and today I will be make a small overview about our service named Sille .space, and what we are dealing is see the world around the movements. Sille brings a new level of visibility on ground, infrastructure, real estate deformation. We create a new layer which brings a new point of view to our client's object. It is the movements that see the satellite eye. And the benefit about our clients is that the decision makers can see the larger picture, and help this helps to do them to wiser decisions, because the contact measurements is also good, but sometimes the deformation levels is not only the house based, but the wider area that's seen in contact measurements. Sille can monitor the object size is not matter. We can measure, for example, country, city level, or specific object level. We can measure the shifts, deformation in time, the smaller shifts in shorter period, sinking, subsidence, and all other such things. The good benefits about satellite monitoring is that then we can measure all worlds. The data is covered all worlds, so we can help our clients in any place in the world that we want to monitor. The main object that we are focusing is mines, dams, and production plants. So we can see the buildings, docks, infrastructure, dams. After the hazards, we can see the hidden movements after the hazards. And damages is where shifts in a shorter or longer periods. Our clients' variety is also very large. Everybody who is interested in movements is potentially our clients, but mainly the engineering companies, energy companies, mining, governmental organization, city authorities, and so on. Usually we usually use Sentinel-1 data. SAR is SAR data. SAR is active remote sensing method. It is based in synthetic radar application where microwave length transmitted and echoes is collected. The gathered echoes data will be resampled and produced images will be produced. The main benefit in SAR compared to optical data is that atmosphere is not a barrier for microwave. So we can collect and promise data to our client every time when satellites flying over the object. It is not related by weather or light conditions. It can be done in nighttime also. But the other side of the sausage is that the resolution and the interpretation of the SAR data is a bit lower than optical data. It is usually needs optical data as help for our clients to understand what our layer is meaning. The rough parallel to compare is by human senses. The RGB optical image is like a vision sense, and the SAR data is like a hearing sense. The usability of a Sentinel data is good because it covers all world landmass, at least 12 days interval. The data is consistent and there is no big data holes. All measurements will be archived and we can use them any time when our clients needs and our client needs. So we have also covered it not only by space, but we have also covered it in time. So we can roll back the time of the object until the Sentinel-1 mission is started. It's October 2014. The longest time series now is already contain already more than 300 acquisitions. Of course, we are look even earlier because we can analyze different SAR data, and SAR satellites is gathering information about Earth already from 1992. But look so back behind is not usually needed our clients because business is forward looking always. It's a method that we use. It's called interferometric SAR, shortly INSAR. One of the products that SAR offers is phase level. It contains the length of a last. It contains length of a last wave that is going to antenna. And one image, phase image, has not much information. As you see in the screen, it is scratchy as old TV without antenna. But if you take two images, place them accurately to each other, then the waves are interfered. The interference is a physical phenomenon. What's happening when two coherent waves are joining together? Each and they form fringes, and every deformation fringe in interferogram is half a wavelength of moment. In line of sight, which means that the measurements, deformation measurements, is show that the object is moving toward or away from satellite. As I said, the deformation fringe is 1/2 of a wavelength. And if you want to calculate deformation, then we have to get one point of the interferogram as non-movement, and we have to count fringes between reference point and the object that we want to see. And then we define them to define fringes count to the meter measurement. I have to mention that SAR is a relative measurement, so always have to be put a reference point that is not, as we assume, that is not moving by other reference, other points. To go forward, we in time we are dealing with multiple interferograms. So we have to tie the interferograms wisely together with different methods. And after the calculation, we got nice time series to see how the object is moving historically and to monitor it to a future time. So adding images to a time, we can see how the deformation model deformation is acting. To not say just talk, I get some examples in our projects. First is tunneling, when we can see that when the red area is the new metro line that is digged a few years ago. The time series is about 3 years of data. For example, the Japan, there is not a good land. We're making artificial island, and the artificial island usually sinking quite a lot. The behind looking is good for after the catastrophe. Also, as you've seen in our images, we analyzed one dam that was collapsed, and the analysis clearly show that there has abnormal movements in broken point before the catastrophe. So this time the view, the catastrophe was visible in SAR by SAR, that the movements are abnormal in this point of time. Of course, there is a lot of digging and mining in our world, and here is example where the underground mining is subsidizing slowly, and it is behind the city, so it is seeing that, and the monitoring of such objects are seeing that the subsidizing is accelerating or stabilizing or is going on. One example in landslide where catastrophe is said before that is coming. This is landslide from Bolivia capital La Paz, where you can see the movements, clear movements in a landslide area before the catastrophe happened. And the last one, last example where it's also getting over our news is Florida Piney Reservoir, and after analysis, we saw a clear point that was broken. Clear view in SAR that the area that was broken was visible in SAR before, and because it covered the vegetation, then that 1 or 2 points in vegetated area indicate that the area is wet, and it's much better to reflect it by SAR image. So, and this was almost 10-meter accuracy in the place where the exact broken point was getting. And that's all. Thank you very much.